question 2. Al walked at a constant speed of 1.5 metres per second between A and B. Ben jogged at 3 metres per second northwards between A and B. Describe their velocities for the rest of the journey if they maintain the same speed. So just check you know what they're asking here. This is a little bit like the circular motion, where you've got the same magnitude all the way around, but your direction is changing, so therefore your velocity is changing. It's a little bit like that. They are not asking for you to work out the average velocity between A and C when it reaches C. That would be more complicated, because that's when you would have to use your equation for your average velocity equals displacement over time. It is not asking that. If you don't know what I mean there, don't worry about it yet. You'll get it in a later unit. Okay, so let's start. We've done A to B, or that's been done for us. So we need B to C. So for Al, he is travelling at 1.5 metres per second, but they're after a velocity, of course, velocity. So we have to give a direction. It's going to be east. And then Ben is going to be 3 metres per second, and that is also going to be east. So really all we're doing is adding this component in for direction. Okay, and then the next one is C to D. So Al will be 1.5 metres per second, got them mixed up there. And this time he is going south. And then Ben will be 3 metres per second, also south. And then finally, the return part of the journey from D to A, where Al is going to be 1.5 metres per second. Now it's this direction. So for our velocity, we need our direction component to say west. And Ben, obviously, still at 3.0 metres per second, and he is also west. So the magnitude has stayed the same. We've just changed the direction each time.